So now that you all are masters at writing things in scientific notation and ordering and comparing numbers using scientific notation, today we're going to talk about how we're going to use the laws of exponents we've been learning to do operations with those numbers that are in scientific notation. So today, the first one I want to do is I want to try multiplying numbers that are written in scientific notation. So let's go ahead and find the simplified form of, I'm going to make my pen a bit thinner. The simplified form of 3 times 10 to the 5th times 5 times 10 to the negative 12th. Okay? So, we're going to multiply this. Think back to if we were multiplying 2 times the square root of x times 4 times the square root of 2y. What we do in that case is we do the outsides multiplied by one another, so 2 times 4, and then times the insides multiplied together, so x times 2y. And what that comes out to be is 8 times the square root of 2xy. So that's kind of a review. Well, this is a similar idea. We have 3 times 10 to the 5th times 5 times 10 to the negative 12th. And so I'm going to go ahead and use two different colors here. We have 3 and we have 5. Those are kind of like our outside numbers like we were just dealing with, okay? And then we have 10 to the 5th and we have 10 to the negative 12th. And those are going to be kind of like our inside numbers, if you will, right? So we can break this up. We're going to do 3 times 5, okay, times 10 to the, we know it's going to be 10 to the because 10 to the something, because this is scientific notation and our base is always 10. So now this is essentially saying times 10 to the 5th times 10 to the negative 12th. Well, using our exponent rules, we can simplify this. We can simplify this by adding the exponents because we are multiplying like bases. So we're adding the exponents. The other way you could do this is put it in your calculator. That works well too. Okay, but we're going to do 10 to the 5 minus 12 because it's 5 plus negative 12, which gives us negative 7. So this is going to be 10 to the negative 7th. Now, we're not quite done because we need to simplify this. 3 times 5 is 15. But what's wrong with this? This number 15 is greater than 10, so it does not satisfy our conditions for being written in scientific notation. So we're going to do the same thing that we've been doing. We need it to go to 1.5, so that means our decimal point is going to move 1, and it's going to make the number smaller, so we're going to have to make our exponent on 10 a little bit bigger. So it's going to be 1.5 times 10 to the negative 6th. Okay? So, let's give this one, let's keep going with this. Okay, so now we're going to try another problem just like that, and it is going to be an application kind of problem. So at 20 degrees Celsius, 1 cubic meter of water, so that's meters cubed, has a mass of 9.98 times 10 to the 5th grams. If each gram of water has about 3.34 times 10 to the 22nd molecules, how many molecules does 1.13 times 10 to the negative 7th meters cubed of water contain? So we're going to have to do a little conversion. So the way I've always learned how to do conversions is we're going to do railroad tracks. Basically, the whole idea behind railroad tracks is that you're canceling out the units. So we're starting with 1.13 times 10 to the negative 7th meters cubed. So we're trying to get to molecules. That's what we want to know. So we're going to have to use a conversion factor that will help us convert between meters cubed and molecules. So we want to cancel out meters cubed, so we know that we're going to be having our conversion factor, we're going to have the meters cubed part in the bottom because we're eventually going to be dividing by that. So that's going to cancel out meters cubed. So we have a mass of, each gram of water has about 3.34 times 10 to the 22nd molecules. Sorry about that. No, we need to do meters cubed. Sorry. So we're looking first for 1 cubic meter. So 1 meter cubed has 9.98 times 10 to the 5th grams. Okay, so now our units are in grams, which is still not what we want. We want molecules. So we're going to be dividing by grams, and we're going to hope to get molecules as our final unit. So the number of grams we have in 1 gram of water, there are 3.34 times 10 to the 22nd molecules. Okay, so now what we see is that essentially our meters cubed is being canceled out by a meters cubed in the bottom. Our grams in the top is being canceled out by a grams in the bottom, and then all that will be left is molecules, which means that we will, after we do the calculations, we will have what we want. So we're going to go ahead and do this now. So we have anything that's in the top you multiply, and anything that's in the bottom you divide. Since all we have are 1s in the bottom, we have nothing that we're only going to be dividing by 1 times a 1. And then in the top we have 1.13 times 10 to the negative 7th times 9.98 times 10 to the 5th times 3.34 times 10 to the 22nd. Okay, so let's simplify that. We'll take our outside numbers. Oops. Our outside numbers in this case are 1.13 times 9.98 times 3.34 times, and now we need our 10 to the negative 7th. So this is what we're doing now. So we did 1.13, 9.98, and 3.34 right there. And we have 10 to the negative 7th times 10 to the 5th times 10 to the 22nd. So here we just need to multiply these numbers together, which is going to give us 37.7. And we are going to be multiplying that. Now we're multiplying like bases here, so it means we're going to be adding their exponents. So we have times 10 to the negative 7 plus 5 plus 22. So we simplify that again. We get 37.7 times negative 7 plus 5 gives us negative 2 plus 22 gives us times 10 to the 20th. Okay? Now, once again, we have something wrong with our number. We need our number to be between 1 and 10, and currently 37.7 is greater than 10. So that means we're going to need to move our decimal point back 1, okay? Which means we're going to have to add 1 to our exponent here. So we are going to get 3.77, and so again, remember from yesterday, we're accommodating for making this number smaller, right? We essentially divided this number by 10, but we don't want to change the value of the whole thing, so we're going to be multiplying by another 10 here by adding 1 to our exponent. So this is times 10 to the 21st. Okay, so our answer is 3.77. Oh man. 3.77 times, okay, I don't know why that's erasing. 3.77 times 10 to the 21st, okay? Now just for good measure, let's do one more, okay? So again, we're going to do the outside here. 7 and 4, so 7 times 4 times, all right, and now we want to make sure we do our inside, which is 10 to the 8th, 10 to the 5th, so times 10 to the 8th times 10 to the 5th, okay? So I just kind of want to go over one more way. If you're a little bit confused about how do I get it from 74 times 10 to the whatever into, so that 74 is, you know, going to be between 1 and 10, I'm going to do another one. I'm going to kind of show you my thought process behind it, okay? So we first do 7 times 4, which gives us 28. So we know we're going to have to deal with that in just a second, okay? And now if we're multiplying like bases, so we're going to be adding the exponents. So this is going to be 10 to the 8 plus 5, which is going to give us 10 to the 13th, okay? So it would be 28 times 10 to the 13th. This isn't quite in scientific notation, so I'm going to show you another way. We can think of 28 as 2.8 times 10 to the first, right? 2.8 times 10. So if we rewrite this in here, we have 2.8 times 10 to the first times 10 to the 13th, okay? What we can do is now we can kind of combine like terms, keep our 2.8, that's essentially 2.8 times 1, and that'll be times 10 to the first times 10 to the 13th. So now what we get is 2.8 times 10 to the 14th power. Okay? So that's going to be our answer to that one, and yeah, so far so good. Okay. Okay. So now we're going to go ahead and raise this to a power, okay? So I have in front of us the equation for kinetic energy, which is 1/2 mass times velocity squared. So we're going to find the kinetic energy of a jet that weighs 1.3 times 10 to the third kilograms, and it is going 3.1 times 10 to the third meters per second, okay? So we're going to go ahead and plug this in where it goes. So we have 1/2 times 1.3 times 10 to the third times 3.1 times 10 to the third squared. Equals our kinetic energy, okay? And so the first thing that we need to do is we need to deal with this 2, okay? So just like in our laws of exponents, we're going to be distributing this 2 to both of our exponents, okay? And remember, this is 3.1 to the first power, so we can still distribute this 2 to it. So we have 1/2 times 1.3 times 10 to the third times 3.1 squared times 10 to the third squared, okay? Now, using our laws of exponents, I'm going to keep this part the same for now. And we're going to get 3.1 squared, which will come out to, well, we'll do that in a second. We'll leave that as 3.1 squared for now. Okay, and then that'll be times 10 to the third. So because we are raising this to a power, we're going to multiply the exponents together, so that's going to be 10 to the 6th. Okay, and now what we want to do is we want to combine our outsides. So this is still like this, times 10 to the 6th. Okay, so we're going to combine our outsides. So we'll keep our 1/2 here. Then we have 1.3 times 3.1 squared. And then we're going to combine our powers of 10. So we have 10 to the third times 10 to the third times 10 to the 6th. Okay, and adding our exponents, this is going to simplify to 10 to the 9th. Okay, so we get 1/2 times 12.493 times 10 to the 9th. And then we have to do this 1/2, so that's going to give us 6.2465 times 10 to the 9th. Okay, and so now we have to check, is this okay? And yes, this integer is between, or this number, it's not an integer. This number is between 1 and 10. So we know that that number is fine, and 10, we're good there, and 9. So this number is done, and we are finished with that. So if we're just going to go back over that real fast, if I were to do 1 times 10 to the 4th times 2 times 10 to the 5th to the 3rd, then we would distribute this 3 to both terms. So we get 1 times 10 to the 4th stays the same, times. So 2 to the 3rd times 10 to the 5th to the 3rd power. So we get 1 times 10 to the 4th times 8 times 10 to the 5 times 3, 5 times 3, 15th. And now we have outside 1 and 8, so 1 times 8 times, and now we have 10 to the 4th times 10 to the 15th. So we're going to add those exponents, and what we're going to come out with is 8 times 10 to the 19th power. Okay, so that is how you raise one to a power. Okay, so now we're going to be dividing we're going to divide our scientific notation here. So we're going to do this the same way that we were doing multiplying. We're going to divide our outside numbers, and then we are going to divide our exponents here. Okay, so first we have 1.21 divided by 4.81. Okay, so we're kind of going to break up our fraction bar here. So we have 1.21 over 4.81 times, and then 10 to the 7th over 10 to the 5th. So 1.21 divided by 4.81, we're going to do that the same way we divide any numbers. Okay, and that's going to give us 0.251559. So 0.251559. So we're going to simplify that in just a second. All right, and now this, we are dividing like bases, so we are going to subtract the exponents. So our exponents are 7 and 5, so it's going to be 10 to the 7 minus 5. I'm going to write this over. So 7 minus 5 gives us 2. So this is times 10 to the 2nd power. Now this isn't correct yet because this number has to be between 1 and 10. So we need to move our decimal point 1 this way. So what we're essentially doing is rewriting this as 2.5, and I guess let's round this up to 2.52. How about that? Does that work for you? 2.52 times 10. In order to make it bigger, this is going to be times 10 to the 5th. And so, I don't know why I just said times 10 to the 5th. It is going to be times 10 to the 1st. Okay? And then, sorry, times 10 to the negative 1, because we would be dividing this number by 10 in order to get this number. Anyway, so 2.52 times 10 to the negative 1st. And that's going to be multiplied by our 1 times 10 squared to keep our 10 squared. Okay, so we'll keep 2.52 times 10 to the negative 1 times 10 squared. So we're going to add these exponents together. Negative 1 plus 2 equals just 1. So it's 2.52 times 10 to the 1st. And we can simplify that because there's really no point in writing this number as scientific notation because it's pretty manageable on its own. When we multiply that out, we get 25.2 as our final answer. Okay? So just to summarize, let's say if we do 2.53 times 10 to the 17th power divided by 4.8 times 10 to the 5th power. All right, what we're doing again, we're dividing these numbers, 2.53, dividing our outside numbers over 4.8 times, and now we're going to divide our 10 to the power of whatever. Okay, and then we're going to subtract our exponents here. So 2.53 divided by 4.8 is 0.527. I'm going to go ahead and round that one. 0.527 times, and then 10 to the 17th divided by 10 to the 5th. We're going to subtract those exponents, 17 minus 5. And so we're going to get 10 to the 17 minus 5 gives us 12, so 10 to the 12th power. Now we have to fix this real fast. 0.527 is equal to 5.27 times 10 to the negative 1. So again, we have to divide 5.27 by 10 in order to get 0.527. So that's why we're doing 10 to the negative 1 here. So we'll replace this. We get 5.27 times 10 to the negative 1 times 10 to the 12th. So we're going to combine our like terms, or combine our exponents with our like bases here. And so we're going to get 5.27 times 10 to the 11th. And that is pretty much it. So we've gone over these now. Okay, so I have a bookwork assignment for you. All right, you're going to go ahead and work on this until the end of the class. Remember, I'm giving you the odds, so you are welcome to check your answers at will in the back of the book. If you have any questions, ask your classmates, and I'll be back tomorrow, and you can ask me questions tomorrow as well. So we'll go over everything that we've been doing when when I get back tomorrow. So yeah, I'm really looking forward to seeing you. I miss you a lot. And are you ready for your bookwork assignment? Good. Okay, here's your assignment. Woo! Okay, so go ahead and practice. There's only a few problems in each section, so don't be overwhelmed that there's 3 different sections of material that you have to work on. Okay, just work hard, make me proud, and I will see you tomorrow. All right, I'm going to leave this on the screen just for a few more minutes here so that you can copy it down. If you need anything from this video repeated, just ask the sub to rewind back through it, and you could even play this video again while you're working if you wanted. All right? Okay, guys. Thanks.